Hello, and welcome to this week's installment of ClueCon Weekly. This week we have Ann Lee from Nokia Bell Labs, a personality in telecoms, and someone who can really talk about the history, the past, and the future of telephony. So thank you for joining us, Ann, today.
Oh, thank you for having me.
Would you like to give us a quick introduction about yourself?
Oh, okay, sure.
Or not so quick.
I could do a very quick one. I've been in the telecom industry for over 30 years. And so maybe we could talk a little bit about that. It's been an interesting journey, right? I came out of college, so I started with AT&T, and I did not change companies. The companies just changed around me. So I went through the whole journey of AT&T to Lucent to Alcatel-Lucent to now Nokia, and that's been over 30 years. And I started out very briefly on the wireline side. I have degrees in electrical engineering and computer science, but I started out on the switching side for a very brief amount of time, and then decided to switch over to wireless. And back then in wireless, if you want to start talking about history, back then in wireless, we were actually growing just a little bit, but also pulling back a little bit, because when I switched over to wireless, someone asked me, why are you going to wireless? We just hired McKinsey, a very well-known consulting firm. And I think this story has been told everywhere. But they did a market research on whether people would adopt mobile phones. And their conclusion was, we have enough wireline phones, we have pay phones everywhere, even on highways. No need to do mobile phones because people aren't interested. There's no market for it. So for a little bit of time, I think the industry then decided to step back a little bit on whether to do much work there. But as it turned out, it was a good decision later on to go ahead and go forward with wireless, because now we're deploying 5G. Back then, we hadn't even deployed anything. People didn't have mobile phones at that time. While I was growing up, there was no internet, there was no web, and there were no mobile phones. And even when
I was in the middle, I saw cell phones and the internet coming up.
Okay, well, when I started working, we didn't have mobile phones, but I was working on it very early on, and now we're in 5G and 6G. It's been about 30 years. So I was just I have interns, and I was just telling them, and of course they're very young, right? So I was telling them about some of the history and how I lived through the last 30 plus years and saw this basically a revolution occur in our industry. And so sometimes it seems like things can take a long time in technology, but going from 1G to 2G, 2G to 3G, 3G to 4G, 4G to 5G. It actually, even though the architectures really change quite a bit between the generations, for the most part, when you think about how complex technology is, it didn't take as long as you think. Now, there are other things that has taken a long time, right? So like IMS has taken a while.
IMS adoption.
Yes, adoption has taken a while. WebRTC has taken a little while because it started in 2011. It's 10 years now, right? It's taken a little while. Some other things, SMS took a little while. I think it took about 7 years in the US before people started to really adopt SMS. So some things took a while, but the underlying infrastructure of wireless, once the decision was made to standardize and then build and then deploy, it is relatively fast considering all of the players that you have to get aligned and working together in the ecosystem, and then having the service provider deploy. It is actually amazing how fast it can go. And now we're starting to work on 6G and looking at
Well, I'm going to ask you something about that then.
Oh, okay.
Why don't we start from the future? Like, not everybody, well, outside of the people that are actually in the telco proper industry, not everybody even knows there's a 6G incoming. So 5G is actually already done, essentially. It's not out there quite yet, but it's
not, yes, it's not quite done. But you start the previous generation maybe 5 to 10 years before you expect to deploy. I mean, you start the standardization. So we're just at the beginning of that, thinking through what are the use cases that we want to be able to support with 6G, and then what are the capabilities that are needed in order to support 6G.
so if you already know, first of all, if you could quick recap what 5G will bring out to the industry, and if you already know what 6G will bring out, because I don't even know. Like, I'll be honest, it's an honest question. I don't know what 6G is going to look like.
You know that 5G is supposed to provide very low latency, high capacity network slicing, so you can actually dedicate channels, essentially, I guess, to particular endpoints or services for a particular quality of experience, like quality of service and quality of experience, which it'll be amazing. But we're just at the start of deploying that, right? And supporting. So the low latency is necessary for various enterprise, industrial type, and even healthcare type solutions. And it would be to support services that need that, but also devices that need that kind of low latency. And I was just talking the other day to folks about the vision of the explosion of IoTs, mm-hmm. which is happening, happening probably faster on the Wi-Fi side, but that is limiting because you can only go so far with Wi-Fi with your device. It's better when you're able to go anywhere with your device and be able, but there's still things that need to be put in place in order for all of that to really explode, right? Some of it is starting, but you have to have chips available, you have to have the devices enabled, and then you have to have business models and ready for how to support that, right? So if you're going to be selling IoTs devices, for example, at Walmart or some big box retailer, and someone buys it, then they need wireless connectivity with that.
Oh, yeah.
And it's not like it's Wi-Fi. You have to get it from some service provider. And so what is that model? And so there's many different aspects to being that has to come together in order for IoT
for the whole thing to work.
The full thing to work, yeah. So some of that could take a little longer than we expect. We'll see. But then IMS took a little longer than we were expecting. Oh, yeah. Right? It took. We had to get a lot of things in place in order for it to really take off. And one analogy that I like to share with people sometimes is the story about how it was one of these blockbuster movies that took, I think it took took 15 years from the time that the producer and writer of the movie came up with the idea, wrote the first script. It took 15 years in order to get the movie
Quite right, yeah.
Out. It was Avatar. And the reason why it took so long, he said, was because the technology to make that movie possible did not exist. They had to invent the technologies in order for the movie to be made. And so it took 15 years for Avatar, but then it became a blockbuster. So when you go back to the beginning of IMS, and it started in 1999, there was actually, I think in the US, maybe roughly half the households had internet access. And we started internet access over the phone lines, right, with modems. We didn't have these fibers going everywhere. And then there were we had feature phones. There were no smartphones, right? Wi-Fi was just starting at that time. SMS was just starting around that time.
What time was Wi-Fi actually coming out? Was it something like 96-ish?
It was towards the latter part of the 1990s, yeah, I think. So it really was just about starting at that time. And so many things were not in place yet. And we had this idea of being able to enable services, and we had the idea of the service broker and all of that in the IMS architecture. And later APIs came along, right? The kind of APIs that we have today. But so there were all of the, and plus 3G, when we started 3G1X, I remember I was in the lab testing some voice over IP over 3G1X, and 3G1X was not deployed yet. So we were testing 3G1X, and 3G1X is not broadband, it's more 2G data, right? So we were really and IMS was originally started in wireless, on the wireless side. So the idea was to IP enable, it was part of the all IP plan for wireless. And so we, even back then, I think the decision was just being made in the industry that IP was the direction of the future.
Yeah.
As opposed to ATM, because there was a battle of ATM versus IP, right? That was about that time that it looked like, okay, it looks like we're going IP, so let's go all IP. So this was right before the .com and the telecom bust, and so at that point in time, I think everybody was very optimistic. Let's go gangbusters. Let's go all IP. Let's do, even though things aren't all in place yet, we'll invent those technologies along the way to get to that endpoint. And so just like Avatar, we'll invent the technologies to make the movie possible. We'll invent all the technologies needed to make voice over IP and all the other multimedia services that we were envisioning happen. But we have to invent those along the way.
So for a few people that don't know, IMS is actually the IP Multimedia System, and it's the underlying, I will call it the underlying infrastructure for the current generation of telephony. That's pretty much it. So it encompasses everything from traffic to application servers to the communication layer to the data and analog conversions. It's all in there. So at what time was IMS started, actually? When did it start? Like the first idea is the 90s, earlier, maybe earlier even.
It was 1999 when 3GPP was asked to start standardization. So there was a consortium called 3GIP of a number of vendors and service providers. So AT&T was a part of it, Lucent was a part of it. There were a number of other vendors, and Nokia probably was a part of that. And the discussion was around, should we go all IP? And the decision was made, yes, let's go all IP, right? Because it was around 1998, 1999. And then once the decision was made, then they went to 3GPP and said, let's start standardizing. And the first release of the standards were expected to be in release 2000. And I think once so it was very aggressive to think that in 1 year we're going to have standardization, at least the first release, done in about a year. That didn't happen, and so they renamed release 2000 to release 5, and then we went from there. And 3G at that time, 3GPP was focused on GSM and then UMTS. And there was a 3GPP2 that was standardizing the CDMA side. And after the crash, we decided to combine the efforts of 3GPP2 and 3GPP. So there was IMS in 3GPP, and then there was an equivalent architecture called MMD in 3GPP2. And we decided that we were going to combine that effort, and it was going to be IMS from 3GPP. And then eventually, wireline, we brought wireline in as well. So the standardization for next generation wireline telephony then adopted IMS. So there was no reason why IMS was really access specific. Just like today's other types of IP communications, you could run that over any kind of path, IP path, whether it's over the air or it's fixed. So
I was wondering, you were part of the original WebRTC. You were part of the original WebRTC effort, right? So since WebRTC is very dear to our hearts, like I've been working with WebRTC for the last 10 years, and SignalWire in particular has been, and Friswitch and all the other things it's very interesting to us. So can you tell us a bit about the starting days in WebRTC, and why do you feel like it took so long?
Yeah. I haven't done as much of a retrospective on WebRTC as I have in IMS, and looking back at, well, why did it take so long? And it makes sense what has happened with IMS and why it took so long, because so many players in the ecosystem had to be all aligned in order for it to move. Plus, we had to invent new technologies. I got interested in WebRTC once I heard about it, because even before that, we were thinking that with IMS, if we're going to go IP, we're not just going to do just basic voice, like the PSTN did, support that, but we want to be more innovative. And so I had this thought that when Facebook came, so there was MySpace, and then Facebook came along afterwards. And I was thinking at the time that, well, if we can put IMS services onto Facebook, maybe Facebook could compete better with MySpace. Obviously, they didn't need that. But at the time, I thought that would be a very interesting
IMS services, so telephony services directly on Facebook.
That was what I was thinking, and that's how I ended up getting my team, and I got Facebook accounts to start to do some prototyping. And there was nothing called WebRTC at the time. There were plugins and there was Silverlight, and so we were trying we were trying to build a client that way onto a web page, and
it wasn't great. It was usable, but nothing there was anything but great.
Right. So when I heard about WebRTC, I got excited. I thought, oh, maybe this idea that we had earlier can actually come true. that we can start to put communications on web pages. And it doesn't have to be Facebook now. It could be other any kind of portals, web portals. It could be retail. It could be healthcare. I mean, so
there's a lot that's still unfulfilled in WebRTC even. Like
yes, yes. So what took so long? It doesn't have. I think it didn't have this exact the same kinds of challenges that IMS has, because IMS had many more challenges. You had hardware challenges as well as software challenges, and then business challenges with because yeah. So, but with WebRTC, you would think, okay, this would open up new markets, but very early on at the beginning of WebRTC, I think too that there was also a lot of hype over what it can do. And it was going to be this peer-to-peer browser type new communications service that might take over all of communications in some people's minds. That's the impression that I got. And I thought that's a little too ambitious. I just want to use it to enable.
Then we found out firewalls exist.
Yes. So things just, yes, you can't anticipate everything that you might run into when you first start and you have all this, you're wild-eyed and so hopeful over what could be, but the reality is.
I have a consideration/question for you. Do you think that the fact that IPv6 wasn't as successful as we originally all thought it would happen had an effect on other things being held back? Because WebRTC has always traditionally been about networking issues mainly. Like that's the main problem with WebRTC. And it feels like from what you're describing that when everybody was starting thinking about WebRTC, we were just waving those problems away by saying, well, everybody will have an IPv6 address, so it will always work. And it feels like that's been part of the, not the problems, part of the delay even.
Part of the delay, and I think WebRTC was also sort of, I don't know if it was sold as part of HTML5, which also was another thing that took much longer, right? That whole vision also took longer than we anticipated. So maybe there were dependencies that didn't work itself out in the time frame that we were expecting it to happen. So, but now we're starting to see more capability, more offerings that have WebRTC built into it, and just like I think what we're doing right now with SignalWire. So I've become hopeful again. I at the beginning I was very excited, and then things took longer and longer, and I'm actually focused now on artificial intelligence, but I do have a project that's prototyping in WebRTC, but it's not necessarily my main focus because it's taken a while. But now that I see that many things have been overcome, this might be a good time to go and revisit and move forward. Sometimes timing is everything, right? And being able to recognize and estimate how long it takes to get to the ultimate goal. That's something that you learn over time, and still sometimes you may not realize, you may not anticipate something that comes up that, but you try, you try to
So since you've been, since, as you said, standards become, well, people start looking at standardization and figuring out how to make things work, etc., years in advance, even 10 years in some cases. What's the newest thing you just recently started looking at that will come in no less than 10 years and will be interesting? What is the latest idea that has been coming up? Like the last, if you can't tell, I mean, if you can say, I mean, the latest idea that came up and you can talk about.
So
it's all trade secrets.
Yeah, I'll just say in general, there's a lot going. So there's a lot. It's technology itself is very exciting, right? And AI is an area that is very it's just exploded in the last few years, and even without breakthroughs, though I believe there are breakthroughs coming, but even without breakthroughs, the existing technology that is out there now and continues to people continue to put into open source is just incredible, and AI is going to be everywhere. It is literally going to be the new electricity or the new oil or whatever metaphor you want to use, but and it's going to change the way we live our lives, just like mobile phones have changed the way we live our lives.
Definitely.
The web, the internet has completely changed the way people live. AI is going to change the way people live.
So we need to start who's not yet working on machine learning and AI needs to start learning something.
Yeah, and it'll be a part of telecom. I mean, people are making.
Oh yeah, I was about to ask. What do you think? What do you think AI is going to be in telecoms?
Oh, it's being, there's the architecture is being defined even in 5G and ETSI, in NLB and 6G to support AI. Right? We need to make sure that we have the data that's needed that would be used for training AI models. We need to be able to have those AI models get access to that data in a very easy and immediate way, depending on where you're using the AI, because you can use AI literally everywhere, right? We're looking at, and I can say this because we've published some papers on using AI to as transceivers or AI models. But we can use it everywhere, right? We can use it to make zero-touch networks. We can use it as the networks become more and more complex. You just can't have just human engineers and technicians managing the network. You need a lot of help. You need intelligent tools to be able to help do root cause analysis and troubleshooting, for instance.
What is a zero-touch network? It sounds like a very... Yeah, I don't know, I'll be honest.
It's almost, in a sense, the next plug and play.
Oh.
Right? So it's an automated operations and maintenance for networks. So we're going to get, we won't become completely automated anytime soon, if at all. But we do need to have automation because we need to solve problems quickly. And networks are not perfect. They'll never be perfect, but they need to be able to either fix themselves or they need to be able to be, they need to provide the information so engineers can fix them quickly. You don't want downtime to be too long with any network. You can't have the service be down too long. So we need intelligent systems, and AI is also needed to make the systems as efficient as possible from an energy perspective. Not just because we want to be good citizens of the Earth, but also, from an operations or OpEx perspective, you want to reduce costs as much as possible, right? So if you can reduce the amount of energy that you use, you reduce costs. So there's a financial incentive for reducing energy, and if you can do this intelligently and use AI agents to help you with dynamically adjusting parameters, load balancing, dynamically more efficiently utilize your resources, any of the resources in your base station or in your network, then you can potentially get to maximize your capacity while minimizing utilization of your resources, including energy.
That's super interesting. I mean, we've been doing some research about AI and using AI within SignalWire, but there's so much to build. Well, to be honest, zero-touch networks sound like something that will need IPv6 at some point.
Yes.
So yeah,
we'll get there.
Yeah, eventually, when IPv8 comes out, probably someone will start using IPv6 at this point. I don't even know why it wasn't, but it really does solve a lot of problems. Well,
I think there were some people who were even thinking about coming up with something completely new and replacing the IP networks, but I don't think that happened. That worked out.
I don't see that happening ever. Like, compatibility is necessary at the stage, because otherwise, nothing will ever work. Yeah. Cool. So, well, thank you very much for joining us today. It was a great chat through history, future, and past. We sort of gleaned there's something interesting coming up you can't really talk about, so we're excited to see what that is. And remember, 6G is out there. So
yes, it's coming. It's coming.
And thank you very much for joining us today. And well,
thank you for having me. I enjoyed it.
Oh, I'm happy to hear that. So for all the audience, see you next week, and thank you for joining us.
Okay.